A pleasant day for each and everyone, and good afternoon. We are Group 8, and we are presenting our research titled Improve Flexural and Compressive Durability of Concrete by the Use of Coconut Husk Fiber. Please, next slide, please. Our researchers for today are ARRIOLA, Chester L, and CADENAS Casian L, MALUBAY Ruferd F, YADAO Sunder T. So, for our research gap and reasons to conduct this study. Many studies and research projects have been conducted to investigate the various aspects of coconut husk concrete, such as its strength and elasticity. They have frequently examined the properties and capabilities of concrete, but they have not always sufficiently investigated whether the length and amount of coconut husk fiber affect the strength and durability of the concrete. The researchers also conduct the study in order to identify whether the amount or length of the coconut husk fiber affects the flexural and compressive strength of the concrete. The researchers also conduct the study to improve the compressive and flexural strength of a concrete using coconut husk fiber. For our statement of the problem, research question number 1. What are the materials needed to improve the flexural and compressive strength of the concrete? The material used to improve the flexural and compressive strength of the concrete is coconut husk fiber. Coconut husk fiber falls into the category of hard fiber due to its high flexural rigidity, which is 1,100 micronewtons per millimeter by FAO 2013, and a large diameter of 320 meters. It possesses highly variable fiber length of 180 millimeters and a lower modulus of 200 dyna, and a tenacity of 11.25 strength and elasticity by BASU 2020. Due to its high flexural capacity, it can also support the concrete to withstand earthquakes, which is supported by Ali M 2014, where it stated that composites like concrete entirely depend on the reinforcing materials for toughness, as concrete itself is brittle. This can be achieved by adding fibers to the concrete. Coconut fibers can be used in concrete to improve its properties. It may be noted that coconut fibers have the highest toughness among all natural fibers. Munawar et al. And Sachanarayana et al. Reported strains of 24% and 39% respectively for coconut husk fibers, whereas other natural fibers have strain in the range of 3 to 6%. Please next.
Statement of the problem number 2. What is the optimal amount of coconut husk fiber needed to improve the flexural and compressive strength of the concrete? In order to compute the right amount, the researchers computed the volume of each concrete by measuring the concrete mold dimension, which is 20 by 20 by 13 centimeters. In order to compute the right amount of coconut husk fiber that will be mixed in the cement, coarse aggregate, fine aggregate, and water, the researchers computed a 1.5% volume amount of concrete using the given dimensions, which is supported by Ali et al. 2022, stated that the study claims that adding 1.5% of coconut husk fiber by volume to concrete increases density by 15% as compared to standard concrete. The computed volume of the concrete mold is 5,200 cubic meters, which is multiplied by 0.015, which is 1.5%, which will be converted into 78 grams. The table shows the values of the materials that is used in the experiment. Next slide.
Statement of the problem number 3. What is the length of the coconut husk fiber using the computed amount of coconut husk fiber to improve the flexural and compressive strength of the concrete? The table shows the length of the fibers used based on the computed amount of coconut fiber, whereas the computed mean is 53.33 millimeter. The researcher computed the force value in the table, wherein F is equals to mgh. Force is equals to mass times acceleration due to gravity times height. The table shows the amount of coconut core in grams and in millimeters and the force exerted.
Next is conclusion. The researchers conclude that to get the right amount of coconut husk fiber that will be used in mixing concrete is, it must first get the volume of the concrete and then get the 1.5% of the concrete's volume. As for the right length, the researchers conducted a simple drop test wherein they dropped the concrete within 5 feet of the ground. The researchers then conclude that the optimal length of the coconut husk fiber that should be used in reinforcing concrete is 50 millimeter, which is the right amount based on the conducted drop test. As for the recommendation, in order for the data gathered to be reliable, researchers suggested that future researchers and innovators conduct compressive and flexural strength tests in laboratory using machines to accurately track the specific flexural and compressive strength of the coconut husk reinforced concrete. Due to lack of time and funds, the researchers were unable to conduct a compressive and flexural strength test, which is recommended to further progress the study and accurately state the whole result of the coconut husk reinforced concrete. The researchers are also recommended to compare the data gathered to past coconut reinforced concrete related research to further understand if the amount and length of the coconut husk fibers really improve the flexural and compressive durability of coconut reinforced concrete.
Presentation for today. Thank you for watching our video. Thank you very much.